Hello everyone, welcome back to the another session in the course Design and Analysis of Algorithms, Unit 1, Topic 2. And this topic is about asymptotic analysis. Now let's see what is asymptotic analysis. The asymptotic analysis, it's a notation to represent computational complexity of algorithm. In the previous video, we understood about algorithm, and every algorithm requires the amount of time to complete the task, and every algorithm also requires space to store the instructions. Now, this time will be vary from algorithm to algorithm. And truly speaking, this time will be vary from input to input. The space is also the same. Space will get vary from instructions to instruction. Now, asymptotic analysis, it is a notation to represent computational complexity of algorithms. And that too in a function. We'll use a function to analyze the computational complexity in terms of time storage. How much time is required to complete one algorithm task? How much space is required? These two things we are going to analyze. Now, I told you here clearly, time is different, or time will get vary from input 1 to input 2. For the same algorithm, when you are changing input variable or input number, then obviously the time complexity will get changed. Now, respective to this behavior, under different scenarios, typically categorized as best case, average case, and worst case. All these different behaviors will get will be defined in terms of a function. Okay, and these functions will use some symbols, and that are what we used to call big O notation, omega notation, theta notation. In the next video, we'll be going to see about these three. But let us know how to define best case, average case, and worst case. Now, what is best case? Best case is the algorithm which will take the lowest possible time. The lowest possible time is what? Best case. Now, this best case analysis involves identifying inputs for which the algorithm runs most efficiently. And this best case scenario is not always the most common real world usage. And average case is what? Average case analysis consider the performance of an algorithm when given input data that is randomly distributed across all possible inputs. And we have the other case, which is worst case. Worst case is what? Will take highest time. Okay. Now we'll see some algorithm example to understand more about this. So in this key points also, I mentioned how analysis will be for each behavior for an algorithm. So that's what we wrote some points. When analyzing the algorithm, it's common to focus on worst case performance because it provides a guarantee on how the algorithm will behave in the most challenging situations. So even the average case will take all possible inputs. We'll take all possible inputs for average case. And for the best case is what? We'll take the lowest time. That is what your best case. Now here we go with some example. The example is what? Linear search. Linear search example, we all know about this linear search, that finding the element with sequential searching. Now let's see. These are what the numbers which are arranging in one sequential manner. I wanted to find the element. Let's see, my key element is 10. So what we will do, as we arranged all these elements in sequential manner, we will be comparing the available element in the array with the key element. That's what the algorithm what we wrote over here. So algorithm linear search, array of elements, size element and target. And target is what? My key element. Now, so I'm taking array of elements. For that I took for loop. Now here my search operation will go. As it is linear search mechanism, we will be checking with each element of array with the key element. When the key element is exactly matches with the target element, array element, then we'll return index of the element. Correct? Now, so what you have to understand from this is, my key element, if it matches with the first index, what do you mean by that? Linear search operation took lowest time, because searching operation was successful in the first attempt. So that is what the best case. What do you mean by best case? Lowest time. Now there is an average case also. That's what I wrote here, analysis of linear search algorithm. We are analyzing how much time it takes. That is what analysis, right? Now, best case is what? When the key element is in the first index, then the best case complexity is big O of 1. Now, what is the worst case? Worst case is what? The longest element. The longest time. The longest time in the sense, when you are searching the key element and the key element was available in the last index. So all these comparisons are required. That means total how many comparisons we would require? N comparisons we would require. So worst case is what? Presenting the key element in the last index, and that is what? Big O of N. What is average case? Average case is what? We'll check with all possible inputs. Not the first, maybe the last. Not the first. It may be of second, it may be of third, it may be of fourth. All possible inputs. So we will be saying average case big O of N. Even the average case may be of N by 2. If you apply logarithmic on both the sides, you will get log N average case. So this is what actually analyzing the algorithm, how much time it takes and how much space it takes. So this is about asymptotic analysis. Thank you all.